Okay, this is Intermediate Algebra, Chapter 10 Review, Part 2. As I mentioned in the previous video, there would be two parts. So, if we have a problem such as the 2 square root of 12 plus 7 square root of 3. Well, I want to combine these. Well, first off, right now I can't because I have square root of 3, square root of 12. They're not like terms. Well, let's see if I can break them down. Well, the square root of 12, well, I know that 4 times 3 gives me 12, and 4 is a perfect square, so I can rewrite it as 2 times the square root of 4 times the square root of 3 plus 7 square root of 3. So this gives me, well, square root of 4 is 2, so 2 times 2 times the square root of 3 plus 7 square root of 3. Well, 2 times 2 is 4, times the square root of 3 is 4 square root of 3, and then I plus 7 square root of 3. Well, I can't break down the square root of 3 any further, and they both have radical 3, so therefore I can combine them because they are like terms. So 4 square root of 3 plus 7 square root of 3 is 11 square root of 3. Now let's say I have one where I'm combining variables, I'm combining radicals, but now they have variables with them. So suppose I have the square root of 4x cubed minus the square root of x. Well, let's see if we can break this down. Well, the square root of 4 is just 2, but this x cubed is a little tricky. So if we think about it, okay, well, I could split this up into square root of 4. We know that's a perfect square, perfect square, times, well, I need to find, let's see, I could split this up into the square root of x squared times the square root of x, because the square root of x squared times the square root of x is square root of x cubed. And I have all this minus the square root of x. So, square root of 4 is 2 times the square root of x squared, which is x, times the square root of x minus the square root of x. So this one's going to be 2x radical x minus radical x. Now, I can't combine these because, okay, well, first off, yes, they both have square root of x in them, but this has an x with it, and this does not. So therefore, they're not like terms. So that means this is my answer. Or if you wanted to, you could you could factor out a square root of x, where it would be the square root of x times 2x minus 1. So that's how you could do that. But generally, if you leave it like that, you're fine. Now, let's say I have two rational expressions that are going to be multiplied together. So I have 3 plus square root of 6 times 3 minus square root of 6. So we FOIL this. But if you notice something here, they're very similar except what? Well, you have 3 plus square root of 6, and this is just 3 minus square root of 6. The signs are opposite. So this is just like having something like a minus b, a plus b. Well, when you FOIL that, what do you get? A squared minus b squared, difference of squares. So in other words, the middle term cancels out. So all you have to really do is multiply the first term here, the first term here, and the second term here, the second term here. So it's something like this. This is just going to be 3 times 3 is 9. And then square root of 6 times negative square root of 6 is negative square root of 36. Well, I got to keep simplifying it. I'll put it down here. I'm running out of room. I apologize for that. So it's 9, and then square root of 36 is 6. So minus 6, which equals 3. So the answer to this is just 3. Okay, so let's clear the whiteboard. Now suppose I have something where, okay, it's 1 plus the square root of 2, 3 plus the square root of 2. Now, this is not difference of squares, so I have to FOIL it out. So 1 times 3 is 3. 1 times square root of 2 is just, well, square root of 2, so it's plus square root of 2. 3 times the square root of 2 is 3 square root of 2. And then square root of 2 times square root of 2, well, that's just going to be square root of 4. So let's break it down. Well, this is going to be 3 still. Square root of 2 plus 3 square root of 2, that's 4 square root of 2. And then square root of 4 is just 2, so it winds up giving me 5 plus 4 square root of 2. And that's the answer to that. So now, let's say you have something where, okay, it's 1 over the square root of 8 minus the square root of 7. Well, we can't have radicals in denominator. It's one of the laws of algebra. So we have to rationalize the denominator. So we multiply by the conjugate. Well, the conjugate is just this. It's the same thing you have in your denominator here with the radicals, except the sign here is the opposite. So it's going to be square root of 8 plus the square root of 7. And not only do I multiply the denominator, but I also multiply it to the numerator. So when I do that, well, 1 times all this is just going to be itself, square root of 8 plus square root of 7. And then down here, well, this is difference of squares again. So square root of 64, all right, because radical 8 times radical 8 is radical 64. And then negative radical 7 times radical 7 is negative radical 49. So for now, let's keep breaking it down. Well, first of all, the square root of 8, I can break that down into what? Well, 4 times 2 gives me 8, so square root of 4 times the square root of 2 plus, well, square root of 7, I can't do anything with that. But then here, square root of 64 is 8, and then minus square root of 49 is 7. So 8 minus 7, that's just 1. This square root of 4 is 2, so 2 times square root of 2 is 2 square root of 2 plus the radical 7 over 1, which is just really 2 square root of 2 plus square root of 7. Now, well, let's say we have x squared equals x plus 2. It's a quadratic equation. Why? Because I have an x squared term, an x term, and a constant term. The way to solve something like this, you want to have everything equal to 0. Well, how can I do that? Well, I can subtract x from both sides and subtract 2 from both sides. So when I do that, I get x squared minus x minus 2 equals 0. So now the AC method, two numbers that multiply to -2 and add up to -1. Well, -2 times 1. Why? Because -2 times 1 is -2. -2 plus 1 is -1. So this factors out to x minus 2, x plus 1 equals 0. I said each of those equal to 0. X would give me, x1s would be -1 and 2. Now you have to be careful here, because you always want to check the solutions, make sure they work. Because sometimes, depending on the kind of equations you get, not all the solutions work, or none of them do, or maybe just one of them. So for instance, if I plug in -1 back into the original here, well, -1 squared is just 1, and -1 plus 2 is 1. 1 equals 1, so that works. I have 2 here. 2 squared is 4. Well, 2 plus 2 is 4. 4 equals 4, so that works. So that's the solution. X equals -1, and x equals 2. So the next one is, now I have something that's a little more complicated. I have the square root of 2x equals x minus 4. So first things first, I need to get rid of that radical. Well, how do I get rid of that square root here, the radical? I square both sides of the equation. So when I do that, I get all this, well, the square root of 2x squared is just 2x, and then I have to square x minus 4 all squared. So when I square this, I get x squared, -8x, and then plus 16. So now I got 2x equals x squared minus 8x plus 16. Well, it's a quadratic equation. Everything has to be equal to 0. So I subtract 2x from both sides. And that's going to give me x squared minus 10x plus 16 equals 0. So now I got to find two numbers that multiply to 16 and add up to negative 10. Well, negative 8 and negative 2. Why? Because negative 8 times negative 2 is 16, and negative 8 minus 2 is negative 10. So this factors out to x minus 8, x minus 2 equal to 0. So that means x is going to equal 2 and 8. But I got to check the solutions. So if I plug in 2 here, 2 times 2 is 4. The square root of 4 is 2. Plug in 2 here, 2 minus 4 is negative 2. Well, 2 doesn't equal negative 2, so that's not a solution. I have 8 here. 2 times 8 is 16. The square root of 16 is 4. 8 minus 4 is 4. 4 equals 4, so that works. So the solution is x equals 8. And the last problem, well, actually, yeah, the last problem, sorry, I was losing train of thought. Suppose now I want to find the distance between 2 points. I have negative 2, 3, and the point 2, negative 2. So the distance between points, I use the distance formula, which is d equals the square root of x2 minus x1 all squared plus y2 minus y1 all squared. So it doesn't matter if I make this x1, y1, x2, y2, or vice versa. So say this is x2, 2 minus negative 2 all squared plus negative 2 minus 3 all squared. So then d, well, 2 minus negative 2, that's 2 plus 2, which gives us 4. We square that. Plus negative 2 minus 3 is negative 5 all squared. 4 squared is 16, and then plus negative 5 squared is 25. So then 25 plus 16 is 41. So the distance is equal to square root of 41, and we cannot break that one down any further. So that is the distance between these 2 points, square root of 41. I hope this video helps, and see you guys next time. Bye-bye.